This section is on derivatives of inverse trig functions. So first couple derivations. If y is the inverse sine of x, we can take the sine on both sides. We get sine y is sine of inverse sine of x, which is x. We're going to not worry about domains and ranges at this point. So the derivative of the left side, sine y, becomes cosine y dy dx, simplistic differentiation. Derivative of x is 1. So the whole point is to get dy dx. So we divide both sides by cosine y. So we have dy dx is 1 over cosine y, which becomes 1 over cosine of the inverse sine of x. And this is where you need to draw a triangle, where if you want to do inverse sine of x, here's your angle, opposite over hypotenuse, so x over 1. This is the Pythagorean theorem to get rad 1 minus x squared, because then you need the cosine of this angle, which is adjacent over hypotenuse, so it's 1 divided by rad 1 minus x squared over 1. So here's your derivative of inverse sine of x. Show the same thing for inverse tan. Inverse secant is more complicated because of absolute value issues I'm not going to go into. So if y is equal to inverse tan of x, take the tan of both sides, which is equal to x on the right. Derivative of tan y is secant squared y times dy dx by the chain rule. Derivative of x is 1. Again, you divide by secant squared, which is like, and multiply by cosine squared. So dy dx is cosine squared y. So now, that means that dy dx is cosine squared of inverse tan of x, because y is inverse tan of x. So how does it get from here to here? Well, let's get another triangle again. We want the inverse tan of x for our angle. So opposites x, adjacents 1. Using the Pythagorean theorem, this is rad 1 plus x squared, and the cosine of this angle is 1 over rad 1 plus x squared. So 1 over rad 1 plus x squared, and you're squaring it, so you get 1 over 1 plus x squared. So here's a list of all of them. Basically, the derivatives for the co-functions are the same as the earlier ones with the negative. All the du dx is just mean, remember to apply the chain rule. So basically, it's everything we've already done with differentiation, but you're just adding on more and more rules. So that's kind of what's happening. We're just adding more and more rules on. Here's some examples. So before we get into differentiation, a little bit of math analysis review. Inverse cosine of rad 2 over 2 is tan of pi over 4. So tan of pi over 4 is equal to 1. For this one, you can use a right triangle again. So opposite over hypotenuse, which is sine. This gives you 12, and the cosine of this angle then here is adjacent over hypotenuse, so 12/13. Over here, same idea, where we need a triangle. So if it's tan, we do opposite 3x over 1 adjacent. So this is your, using the Pythagorean theorem, there's your hypotenuse. Secant is hypotenuse over adjacent. So hypotenuse over adjacent, and then we just clean it up a little bit. And now some of the actual differentiation. Okay, so derivative of arcsine is 1 over the square root of 1 minus whatever's inside squared. So 1 over square root of 1 minus whatever's inside squared times the derivative of this by the chain rule. So that's 2t. And so then you just put the 2t on top and fix up the bottom. Derivative of inverse tan is 1 over 1 plus whatever's in here squared. So that times the derivative of rad x by the chain rule, which would be half x to the negative 1 half. So top I've got a 1, and then this becomes 2 rad x in the bottom, and this is 1 plus x. The 52, derivative of arcsine is 1 over rad 1 minus x squared. Our cosine, negative 1, rad 1 minus x squared, you get 0. This makes sense because actually arcsine of x plus arccosine of x is equal to pi over 2 for any value. And so derivative of the constant pi over 2, well, that would just be 0. And then finally 56, this is going to require some product rules. The derivative of x is 1 times arctan 2x plus x times the derivative of arctan 2x, which is all of this 2's from the chain rule. Then I have the derivative over here. 1/4, 1 over 1 plus 4x squared times 8x by the chain rule. And then I've got to fix up these pieces, which lo and behold they cancel. So one way to think about this is if you were to invert arctan 2x, you would get all this plus c. So looking at it the opposite way. I didn't do any examples with inverse secant. It's just one more rule to apply. Basically, you're just applying this rule instead. Remember with the cofunctions, it's the negatives. You just tag that piece on.